We try to, this first part of the afternoon will be like that. So we start light, but you will see the fiber to the node will be the final shot. But then we're going to have the break. So now we're going to see the indoor version of what we saw this morning. You more or less know everything now about the concept which is behind. So we can really start from a video, because after lunch I'm also a bit tired. I will ask a friend to help me to introduce you that. Welcome, I'm Alessandro Pirri and I'm the Fiber to the Home responsible for Prysmian Cables and Systems. In the era of digital communication and mobility, information flow moves faster and faster to reach us everywhere and through different media. Technological development has brought to our homes so many things that were just inconceivable in the past. To get the maximum benefit from the actual and future IT innovations, the most suitable means is through optical fibers. Building such fiber highways will be a challenge for operators, who will have to discover a smart solution combining deployment speed, reduced cost, and long-term reliability. The environments to be covered include rural areas, high-density populated areas, school, offices, airport, hotels, cruise ships, and many more. Prysmian took up this challenge and, based on the long experience gained all around the world, has developed its VertiCasa system. Starting from the original idea of pulling out a fiber from a duct rather than from a traditional cable, different solutions have been developed specifically for indoor application, both exposed and embedded into inside wall infrastructures, as well as for outdoor use. The VertiCasa concept is based on the simple assumption that once a fiber is cut a few floors upstairs, it can be extracted at the floor where the subscriber is waiting to be connected. The VertiCasa riser cable can be installed in the traditional way, lowering it from above, but thanks to its design, the VertiCasa riser cable can also be pushed up from below. In order to extract a suitable quantity of fiber, an operator will cut it a few floors above the subscriber. A window on the cable will be opened with the stripping tool, and the selected fiber unit will be cut. A second window on the subscriber floors is then opened, and the previously cut fiber unit is extracted. Then, the upper window may be closed with a cover, while on the subscriber floor, a breakout unit is installed. The horizontal path to get to the customer is often the most challenging part of the installation. A low-friction drop tube has been fully engineered to host the fiber from the riser shaft up to the customer home. It is first installed as a standard cable. The extracted unit is now crimped to the pulling rope contained into the drop tube, and then pulled into the customer termination box. Finally, the fiber is terminated and the network is ready for use. To meet the most stringent requirements to minimize the visual impact of the cabling, the main components of VertiCasa have passed through a process of miniaturization. Thanks to such a metamorphosis, driven by adaptation to the environment, VertiCasa Embedded is the natural evolution of the system. And when there is no place at all in the indoor infrastructure, VertiCasa can wear a special jacket and can find its way outside the building. After installing the riser cable on the external wall of the building, following the standard procedure, the extraction windows is protected with a waterproof breakout unit, which also allows the drop tube to be sealed, thus protecting the fiber. A suitable head-in assembly then drives the fiber into each apartment ready to be connected. Just a couple of years have passed by since VertiCasa was conceived, and it has already been able to adapt itself to different environments. No matter where you're living, VertiCasa will be able to reach you soon. VertiCasa. The sky is the limit. Well, so you see that when we say that we do things from A to Z, that's it. We start from the fiber, we do the movie up to for advertisement. Hopefully, we do cable much better than we act, but that's a bit.
Fashion sense is questionable too, isn't it?
Yeah, you know. Well, so back to the more.
Just the jacket specifically.
Yeah. Okay, so I think that was explaining quite well also the operational part of the system, but now Matteo maybe will show you how to create this kind of windows, which you saw this morning were done with a tool for outside plant, but here, being the cable much softer, actually the job is even easier. Here we don't have
Takes just 1 second.
1 second. Here we don't have the stripe because this has been designed to be neutral. Why? Because at the very beginning, the idea was to be installed on the wall, visible, and then if you paint it, at least you can paint on it. So you still have the problem to identify where are the strength members, so there is a little sign here on the sheet to do it. As we anticipated a few times, we like the idea to have the system which are a bit sort of a Lego style. So you see that you have a number of items. Here you can count probably 6 or 7. Overall, I think VertiCasa is not exceeding the 10 to 12 different building blocks. And then you can have a different layout. Here, they're just the most popular. So on the bottom, probably for you it's a bit difficult to see, but on the bottom there is the basic solution. When you extract the fiber, you put the fiber into the drop tube when there is the pre-installed rope, crimped and pulled. And then you go in the outlet in the house and make the splice. That was the first things to give a bit more flexibility to the system, because sometimes you may not have enough space, enough length to go to the customer, or you prefer to use a drop cable, or for any reason you may have a problem with the maintenance. You have a break, and you need to find a way to splice. So that was
invented. You didn't extract enough fiber because the length wasn't enough.
Maybe sometimes there are building with a very straightforward riser, and when you are very lucky. But in Italy, I can tell you, sometimes there are buildings built in 1,500 years ago and reshaped during the time. For sure, they were not conceived to hold the telephonic infrastructure inside. So you will found band, something like that. So in different occurrences, you may have the opportunity to hold a splice like that. Let me just comment, if you spotted during the movie, when there was the very little box, and there was a guy which was routing the drop tube into the drop, let's say, the infrastructure, the black one. I don't know if you noticed there was a sort of an enlargement of the tube, because we also find a way to make a splice outside, really a fusion splice with a splice holder, splice protection, it's shrinkable, and then to be embedded into something which is a bit bigger than this tube, so that to have something really flexible and to be left into the horizontal drop when you don't have even space for a little box like that. Another typical application, which is probably today the most, the one which is applied the most in terms of volume in France, is to have a riser box here, intercepting the riser cable, where you extract the module and then you do the splice to a pre-connectorized box. This also, we got another great idea, being Italian, the pizza box, where unfortunately it's not eatable, but you have inside a box, a termination box with a coil of length. This one is 30 meters, 2 fibers, but there is also the whole family of 50 meters for fiber, different length. And then you pull out from here the drop cable. You will see there is another movie later, much clearer, but anyway, you pull out one end and everything is unrolled, so that the installation is made in 2 steps. First, the riser with everything relevant to the riser, and only when the customer wants to be connected, you come with the pizza box and you make the connection. You stay in the customer home just 2 seconds, just ringing, say sorry, plugging this on the wall with 2 screws, or now also with some adhesive tape, and then you perform all your activity in the riser shaft. Again, a variation over a team here is that if you don't have space for such a small box in the riser, you may want to stay a bit outside or just to move. So your concept is the same: extraction, coming here, and making everything, all the drop cables, they go to the customer. So in a summary, the scheme in general is this one. First, install the riser. This is the equivalent of passing homes. Generally speaking, when we want to mention the home passed, you think to have the fiber in the street. But this is true when you have single dwelling units, because in fact, you only have to give the drop. A vertical building can be thought as a vertical street, where all the apartments are like the single dwelling. So if you really want to pass it to be close to the customer just before the drop connection, the idea is to install the riser cable. You have also another advantage here, because in this more or less 13 millimeters, you have booked the space forever. So it means you will never have a problem in the future not to have space enough in the riser to give the service to someone. So the day one you enter and you are ready for the life. And also, when the regulation is not very clear, is a way to step into first and get some sort of priority. Someone is making the extraction all together to get at the same time as the installation of the riser, or you can do later on. The fact is that in the end, you may give the connection only when requested. Or if a regulation of your country is saying, let's do 100%, you can do 100% at day one. Anyway, the scalability is very high. Also, if you think that depending on what you choose, you may also have the opportunity to have different kind of labor skill. Because if you think that, and with the fact that sometimes you use pre-connectorized riser, this is even more enhanced, the first installation can be made by mechanical guys. Pulling the cable, stopping, blocking the cable in the riser, and that's it. And only at this stage, you need someone which is able to understand what is a fiber. Because until here, basically, cable is a cable. The value is when you make the splice, because the splice has to be done well. And on the other end, if the box is pre-connectorized, this is also ensuring you that the quality of the connector, the quality of the connection is factory quality, with a test report and everything checked. So in a summary, these are as a slide of reduction, because when you say, what do you need to reduce? If we need to come back to the slide of Jack this morning, and if you remember, there was a pie chart, and more or less, more than half of this pie chart was not related to the material, By the way, spot the cable is only 4%. So please stop asking discount on cable, because anyway, we don't change. We don't change. If we can give you 50% discount, you have only saved 2%. So, but we will die, by the way, after that. No, jokes apart, what we are trying to really aim and target is the fact that the big the big point of reduction that can really impact the total cost of ownership actually is the installation and the labor cost, this kind of things. This is also why you will see later we also went to China, but China was just an exercise, because for them this slice is very small, because the labor cost is so small that in the end of the day, for them at this point is important the cost of the components. We saw before in the movie that there were 3 different applications. Probably these 2 are quite obvious. The other one, the embedded, was a bit more complicated. This has been dictated, and in fact is on here because the last arrived in the family, has been dictated by the fact that very often in some European country you are not allowed to install any wire visible, not only inside the home, but also in the common areas. So that you must reuse the existing infrastructure, and sometimes it's a nightmare. This one is 10 by 8. Sorry, is 10 by 12. But the one you saw in the picture was 10 by 10 centimeters, something like that. And sometimes there are boxes of circular or 6 centimeter diameter. So here is not the sky's the limit, but your fingers is the limit, because when it's very small, in the end of the day, the fabric is not an issue. By your finger, yes, because you cannot really manipulate. But that's it. It's a constraint. If you don't have any other choice, you must go this direction. This bunch of slides is showing real situations and of the first deployment. This one is from Telecom Italia. You see this modular box is very popular in Europe in general. Is the multi-operator box, which is the way to fulfill with the law that says that you need to unbundle somewhere the customer access. And the best way to do, if you don't want to do in a cabinet, is to do at the basement. So it's sort of a modular box. Here is a typical nightmare, but this one much worse than before. You see, there is everything inside. Steel wires, coax cable for antenna. So you really have to be small, not to be disruptive, also not to cut the service of other story. This is a project in Andorra. Andorra, I think, I don't know if everybody knows in the world where Andorra is, because it's a very, very small country between France and Spain. That was quite popular 7-8 years ago, because they did the first 100% penetration project of fiber to the home. Of course, there were probably 100,000 people overall. But that was the first time that someone tried to put in live a fiber to the home system. That was also very good for us, because you see it was not working in a very special environment, but it's very normal and traditional story. Also here you see the drop cable is obtained by drilling the wall and entering inside. And all this bending here, for instance, were a challenge to test the fact that our installation by pulling the fiber into the drop tube was actually effective. This is on the other side, completely on the other side. This is the paradise of the installer, because you have a tower, 2 shafts per tower, like that, so everything very neat and clean. But nevertheless, the fact that you may add an infrastructure which is still very neat and clean has been very, very much beneficial. In the Netherlands, they've been thinking about that for 5 years, more or less. Now, the deployment started consistently. That was another interesting experiment that unfortunately was a bit stopped by the crisis after a while, because we were in Hungary, where Magyar Telekom, the incumbent, is a subsidiary of Deutsche Telekom. So Deutsche Telekom, which is quite a large operator, wanted to do a country-scale experiment for fiber to the home, And in fact, they did exactly what I said at the beginning. They passed all the building. Pass means that they've installed all the vertical cable, the riser you see here, in the existing infrastructure. That was quite a challenge, but also we learned a lot of lessons about the fact that this system can really enter in poor infrastructure or a bit damaged. So you can really find a way to find a solution on that. And the other beauty is that you don't require a lot of walk-in. You don't require a walk-in in a building to understand distance between the floors and many things, because once you have the basic item, you can really make directly when you're there. Again, we jump from one extreme to the other. This is another. That was the first application where a system that we thought was vertical. In fact, we call VertiCasa. We conceive it for the vertical installation, has been used in horizontal. In fact, why not? But sometimes you are in the box of your own ideas. That was a school, quite rich school, because they do fiber to the classroom. And you see that they didn't have any problem of space, but nevertheless, they found quite interesting this system, because every time you need to drop a fiber at a given distance, this may go. On the same basis, recently in July, I've been in South Africa, and I found that in South Africa, that was appreciated pretty much for the shopping malls, for instance. In a shopping mall, you have 200, 250 shops, and you have quite a lot of churn, so you need to remake the network, or sometimes you open one until the other ones are still not open. So also in this case, the beauty of having a cable laid on the roof around the mall was quite beneficial as a installation time and speed. You're still there. That on the extreme eastern part of Russia, we did an installation to check if -40 was okay for the cable. It was. When I see this slide, I always think that how is easy that an installer may make a green field to become a brown field immediately. So they got all the space they wanted. By the way, they install this way, they create immediately a mess. This was the one I mentioned in China. Matteo was there at the time. It was the first time in the Chinese war for VertiCasa. It was also the last.
The first and the last, yeah.
No, because I said the value of that is really, in terms of cost of products, okay, the plastic box are very cheap because they are very basic. The cable, it costs like the other cable because at the moment, more or less, is the fiber count, the one which makes the cost of the cable. The big advantage is exactly the labor. But I remember the guys watching us and say, labor, we need something to make our people work. So the more time we need to do, the better it is. And anyway, the cost was so cheap that was not. But anyway, it was interesting also because they tried to make some strange application of this one that again brought us new ideas on how you can play and use the different components. Well, but as a summary, these were the one I showed were just some of the project, but the king of the project, the one where we really developed hundreds of thousands of parts, if not probably already close to 1 million for the termination box, is France. France is sort of an example because they've been very pragmatic. I think you know that every time you're talking fiber to the home, the first point to understand who is the owner, what can I do with my competitor, can I keep my competitor out the door, etc., etc., etc. The trend in Europe is that somehow it will happen that you will have to share the network, at least unbundle some part. And for sure inside the building, it's not acceptable that every new operator will have to wire the building. So the agreement consisted in the fact that the four main operators, they sat around the table and they said, let's find a solution. Probably Orange, the biggest, said, I'm dominant. but that's it. So we'll please accept the best for everything and we go ahead. In fact, they found a solution that is very convenient for Orange, but in the end also for the other. What they do, they have a cable of this size, but every module contains 4 fibers. So basically they connect 4 fibers per customer. One tray here is to splice 4 fibers. So. And they have, at the same time, 4 fibers in service, so that you can have data from one, TV from another one, et cetera, et cetera. This probably is not the cheapest solution, but for sure is the one which has enabled the business, because actually is what happening. They are really delivering service successfully. I promise I'm not acting again, but there is a movie which is, we spent one day close to the installation team of Orange in a project in Toulouse, and you see what happened.
One of the biggest challenges in building any new type of fixed infrastructure is in keeping the installation costs to a minimum. The use of pre-terminated and pre-connectorized products plays a key role here. This is especially true in the case of the multi-dwelling unit environment. Optical fiber technology enables the end user to receive maximum bandwidth provision for every type of residential configuration. The small optical cables, supported by some extremely innovative installation techniques, have been carefully designed to be compatible with both new and existing structures, even those found in the oldest of our towns and cities. FlexTube technology combines remarkable handability and an extremely fiber-dense cable design containing up to 720 fibers in a 16mm cable diameter. 3 modular boxes are installed on day 1, with the bottom one assigned to the first telecom operator. The next one is the customer box, and finally on top, a storage box houses the fibers to be used in the future by the next operator offering a service to the same building. The use of a pre-connectorized termination box allows quick and easy installation, minimizing the time needed in the customer's home.
France Télécom est très satisfait des solutions développées par le groupe Prismian. Ces solutions, dont nous pouvons voir ici la partie VertiCasa, permettent de réduire sensiblement le temps de mise en œuvre et d'améliorer la qualité, notamment grâce aux câbles riser préconnectorisés, aux splitters préconnectorisés et aux accessoires associés. Il en est de même des boîtiers d'abonnés préconnectorisés qui permettent aussi de réduire grandement et de simplifier le raccordement des clients au réseau FTTH.
Here we got a French actress this time. Okay, so you saw that this is exactly what is a daily life in France now for the fiber to the home deployment. You see also that they are sort of so they are the car with the fiber on the back. So there is sort of a involvement of the people that really are. They have been able also to create the fact that the people is asking for that. There is a real need, and so that the flow is quite constant, and the pace, from what we can see from the goods we are developing, is quite consistent. And we also see now at the moment that at the beginning they were buying a lot of things for the riser. Now the increase is exactly as well on the termination box, which really means that the things are going ahead. Before we leave, the few slides on this subject, because then I think it's enough about retractable solutions. There was an application that I want to show, just pictures on when RetractNet met VertiCasa. I mean, these two things, which are the main installation concept, starting now also to be installed and adopted by the same operators. Here we are in the Netherlands, in Schiedam, typical environment with windmills. 40,000 homes we are talking about, managed by 8 POPs. P2P network, point-to-point network, because it's an open network. You see that the marriage is getting in the mud, but these are the two systems which are coming. Someone before was asking me if the dimension and the size of the closure probably is something that needs to be said. When you see this kind of cables, and they are with the relevant connectivity, because of course this connectivity is optimized for the needs encountered so far. So operator wanted to solve some problem, and this is the connectivity to solve such problems. Anyway, maybe needless to say, everything is compatible with the standard products. I mean, this is a cable, can be used in a closure, in a dome closure, and everything can be used with everything else. There is not that you use something you are locked in. And this is why, again, you can play with these things together with what you already have in your network. In this case, then the outside plane is branched on the base of the building, and you see that you always find, the other beauty is that you always find a space for your stuff, because among the other services, the other infrastructure, we are already there, you will always find a space for 12mm cables and a box like that, which is really small, is the one like this on the panel, on the board. In this particular case, then the termination is done in a box which is also the ONT, so you don't have a transition point like that. In this case, in the board, you see that you terminate the fiber, and then there will be a jumper, an optical jumper, to go to the modem, to the router. In this case, this particular project was managed with an integrated box. So before we really step out of this topic, I leave the floor to Matteo, which will talk about a couple of things made.
Yeah, so this is something that I calculated 1 year ago, more or less, when we were able to convince Chorus in New Zealand that the solution for them in the multi-dwelling environment was VertiCasa. Just for your information now, Chorus are always using VertiCasa in the multi-dwelling unit. Fortunately, New Zealand is not that big and they don't have so many buildings, which is a shame for us, but anyway. How did we do that? Simple, I calculated, I put down a model, and I calculated in three different ways what would be the cost for terminating the fibers inside the apartment of few customers. So since we were in New Zealand, obviously they wanted to see the comparison with the blown fibers because they use lots of blown fibers and blown cables. And obviously, traditional, conventional solution. And the third one was VertiCasa. So let's see in the details what we did. So the day one, we assumed that a customer popped up and they wanted to have the connection. Day two, a second customer. Day three, other two customers, one of them at the same floor or one of the first two. What happens? Happens that with a few assumptions, you can calculate that the installation of a box in the basement, which is common, it's always needed, obviously. Then the installation of a cable, which we assume that we have 6 customers on each floor, which means you need 12 fibers because under the Crown Fiber agreement, they have to bring 2 fibers per each customer. So 12 fibers up to the riser box, the floor box, and then from there you could splice just 2 fibers per each of them. So the results were that it was quite economical installing the first customer because it's just $1,300. An additional customer would cost you about $600, and to get all the 4 of them connected, you would spend $2,800. These are New Zealand dollars. However, if a customer appears on a different floor, you will need another riser cable. So every time you will need to install a new cable. Every time you will need to access the riser shaft, and every time, hopefully, nobody has touched, has moved, has increased the number of cables inside. So you have no warranty that the riser shaft is available every time. Let's see what happens with blown fibers. So blown fibers make things a little bit easier from a certain point of view, which is not mine. However, you have to install the termination box, the basement box, demarcation box at the bottom of the building. Then you need to install a 24-way multi-duct. 24 is the maximum capacity for a multi-duct. You can't go over that. At least, as far as we know, no manufacturer can make more than 24 tubes in a single multi-duct, which means that when you have more than 24 customers, it's probably not suitable. However, let's assume that you install a branching box at the floor. Then you have your drop tube up to the house of the customer, and on the top of that, you sit down here with your blowing machine, blowing equipment, and you blow all the way up to the termination box. Then you splice, because this one can't be pre-connectorized. So it's a long way. The initial cost, as you can see, is higher than in the conventional installation. Here you spend about $2,100, sorry. An extra installation of a customer is not that cheap as you would expect, because in any case you need to set up the machine, you need to bring there all the stuff. It's not very immediate, and it costs you about $700. And look at that, connecting the 4 customers, it's more expensive than what would cost you installing in the conventional way. And now I show you the magic, VertiCasa. Okay, as Alessandro explained a few times, the movies, etc., the board, you have a highway which is ready since day one. All the customer, if you think about the building like a road, all the floors will be house passed. All the apartments in the building will be house passed. You don't have to access, if you want, the riser shaft anymore, or if you access it, it's just for installing the branching boxes, the riser boxes. And then with the help of a pre-connectorized product, like the pizza box, you can actually install something which is already pre-connectorized all the way back to the riser box and then make a splice. The initial cost is more or less the same of a blown fiber installation. It's a little bit higher than the standard. We're not lying. We're not telling you that it's not that it doesn't cost you a little bit more. But look at that. The cost of an extra installation is just $350, and the total cost is $2,800, which is pretty much the same that you would spend with a conventional installation, but the cable will be there since day one. So let's go into details. This is what happens. You have the total cost of the first installation into a conventional installation is $1,300. With Sirocco and VertiCasa, sorry, Sirocco is the Prysmian name for blown fiber, Prysmian brand for blown fibers. It's actually just blown fiber. You will spend about more than $2,000, which is more or less the same that you would spend with VertiCasa. But here, when you install the multi-duct, remember that in case you need to install more than 24 customers, a second multi-duct must be installed. And so it will add costs over the cost that you have already had at the beginning. And this is the comparison, actually, between the three total costs for the first 4 customers. But so you can see that the Sirocco will cost you more than a conventional or a VertiCasa. But look at the cost of an extra installation. Here is just $350, which means that it's the cheapest for further connections. And the initial cost is not that bad. So I would say that VertiCasa is the winner, absolutely. And so in case of multi-dwelling unit, probably is the best solution at the moment. There are other things related to VertiCasa. For example, what Alessandro told you about France is that we can pre-connectorize the cable. So the riser cable can come already pre-connectorized, which is an advantage, a further advantage. And since we will talk about the pre-connectorized solution a little bit later, I will explain you which are the new trends in this environment. So that's all. All right, if you have any question, feel free. Yes, please.
Has this solution been used for many commercial buildings, say high-rise buildings in CBD?
Alessandro, what Alessandro was telling you is that in South Africa at the moment we have a rollout in the commercial malls, horizontally installed, and yeah, it's not a problem. The highest fiber count of the cable is currently 288 fibers, so it's a big number.
But for the most part, it's been MDUs in residential so far?
MDUs, yeah. I would say yes, but nothing will stop you using it in a...
I think the summary of these two presentations is that probably we need to think a bit out of the box. We first, because let's forget cables. These are containers of fibers enabling you to drop fiber wherever you need. So with this in mind, every time you need to fiber something, no matter if it's horizontal, vertical, whatever. In fact, if you remember the movie that were mentioned, cruise ships, hotel is typical. You have a corridor and a homes. And so every time you have to deliver fiber, you don't want to have loops, because if you use loose tube technology, you need to leave some loop and extract and make these kind of things. Or refiber the common part of the path, because in a riser, typically first floor, second floor, you pass in the vertical in the same space and go to the second, and that's it. So every time you want to avoid to refiber and repass with the cable on some sites where you have been already, this is a good system. Is container of fiber to drop fibers in around. So with this in mind, I think you can really open.
In any case, I'm ready. I'm based in Auckland at the moment. Hopefully, I will be back sooner or later. But if you send me an email with the details of the building that you want to cable, it's not a problem for me. It's just a matter of taking a little bit of time to calculate, and I will give you a spreadsheet where you can see what I did, and I will run through the spreadsheet with you, so everything will be clear. If there is something wrong, we can always modify that. So.